Okay, law of sines and law of cosines deals with non-right triangles. So here's a couple different pictures of those non-right triangles. Law of sines says that if you have a triangle ABC, and those are the labels for the angles, with sides lowercase abc, then these ratios are equal. Side A over sine of angle A will be equal to side B over sine of angle B, which will also be equal to side C over sine of angle C. Or you can flip all of those fractions. They'll still be equal to each other. This works when we have angle side angle or side side angle. I really want you to focus on the angle side angle one. Side side angle doesn't always prove one triangle congruent. I'm not really going to get into that with you right now. And then law of cosines, again, if you have a triangle ABC with side lengths ABC lowercase for the ABC, for the sides, we have three different relationships. Side A squared will equal side B squared plus side C squared minus 2BC cosine of A. Or we've got the other ones for B squared and C squared. So to get A, we would have to square root that right-hand side. The alternate form is so that you can find an angle. And so like cosine of angle A will equal B squared plus C squared minus A squared all over 2BC. This works when you have side angle side or side 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 triangles. So for the first one, for triangle ABC, angle A is 35 degrees, angle B is 50 degrees, and side A is 16 feet. Find the remaining sides and angles. Now, I didn't necessarily give you enough room on your page for this, so you might want to put this on another piece of paper. Start with, just draw a triangle, label the angles, label the sides, and then start filling in what you know. Well, we know angle A is 35 degrees, so I'm replacing A with 35 degrees. I know B is 50 degrees. We know side A is 16 feet. Now, we need to find angle C, side B, and side C. Right now, I can find angle C. I just take 180 minus 35 and minus 50. So angle C is 95 degrees. Now we take the relationship we have an angle and a side across from it. So angle A and side A. So I start with 16 over the sine of 35 degrees. And I want to find side B, so I put that on top of the fraction over the sine of 50 degrees, the angle across from it. Now to get B by itself, I multiply both sides by the sine of 50 degrees. So first type in your calculator 16 divided by the sine of 35 degrees. Hit enter, make sure your calculator's in degree mode. Then take that answer times sine of 50 degrees. Or you can just type in the calculator 16 sine of 50 degrees divided by sine of 35 degrees. Make sure you close the parenthesis after the 50 degrees and after the 35 degrees. That gets us B is about 21.37 feet. Do the exact same thing for C, except this time it's going to be C over the sine of 95 degrees equals 16 over the sine of 35 degrees. Again, this time multiply both sides by sine of 95, and C is about 27.79 feet. Next one, part B. Again, draw the triangle, fill in what you know. We know side A is 24, we know angle A is 26, we know side B is 15. So in this setup, notice I don't have two angles. So the first thing I need to find is angle B. So we do sine of B over 15 equals sine of 26 over 24. Multiply both sides by 15. And then we have to do sine inverse of that fraction, 15 times the sine of 26 divided by 24, to get angle B. Again, make sure your calculator is in degree mode. So one of the things you could have done is you could have done sine of 26 degrees, close the parenthesis, divide by 24, hit enter, take that answer times 15, and then do sine inverse of that answer. That gets us angle B is about 15.90 degrees. Now we can find angle C. We take 180 minus 26 and minus 15.90. Gets us angle C is about 138.10 degrees. Now we find side C, C over sine of 138.10 10 degrees equals 24 over sine of 26. Multiply both sides by the sine of 138.10 degrees. And we get side C is about 36.56 inches in this case. So both of those were law of sines problems. Part C, we have all the sides of the triangle. Side A is 9, side B is 12, side C is 14. So this is definitely a law of cosines problem. So I want to find side A. So I plug in 9 for A, 12 for B, 14 for C, and I start simplifying. 9 squared is 81, 12 squared is 144, plus 196 minus 336 cosine of A. Then I need to subtract off the 144 and the 196. Well, I just added them, then I subtracted them. And then we divide by negative 336. And now I do the cosine inverse of that fraction, gets me angle A, which is about 39.57 degrees. Okay? This is the process that we go through every single time that we solve for an angle with the law of cosines. But you could just plug it into the alternate form. That's the exact same thing that it's asking you to do. Now from here, we can do law of cosines again for each of the sides, or we can switch to law of sines. To find B, sine of B over 12 equals sine of 39.57 degrees over 9. Multiply both sides by 12, and then take the sine inverse of that answer, gets us angle B, which is about 58.14 degrees. And then I could do law of sines or law of cosines to find angle C, or I could just take 180 minus the last two answers, gets me angle C is about 82.29 degrees. Part D, this one a little bit hard on how I labeled it. That capital A means angle A is 75 degrees. Side B is 12, side C is 10. So right now I can find side A using the law of cosines. So A squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 75. And remember always, if I'm going too fast on the video, pause it, write it down, rewatch it as you need to. Start simplifying. 12 squared plus 10 squared is 244. 2 times 12 times 10 is 240. Square root that answer, and that gets us A is about 13.49. Now to find the other two angles, I'm going to use law of sines. So sine of B over 12 equals sine of 75 over 13.49. Multiply both sides by 12, take the sine inverse of that answer, and we get angle B is about 59.23 degrees. For angle C, I'm just going to take 180 minus 75 and minus that last answer, and we get angle C is about 45.77 degrees. Now, application style question. Two ships leave the same port at the same time, traveling in straight paths in a direction that makes a 48-degree angle with the other ship. One ship travels a rate of 15 miles per hour and the other at 10 miles per hour. How many miles are the ships apart after 4 hours? One of the things that helps with these is draw a triangle, label the sides, set up the relationship, and solve. So we've got point A is the port. We got the first, one of the ships travels off to point B, the other travels to point C, and the angle between is 48 degrees. The first ship travels 15 miles per hour for 4 hours, the second 10 miles per hour for 4 hours, and we're looking for that distance in between, that distance apart at the end. Well, the first ship, 15 miles per hour, 4 hours, 15 times 4, that's 60 miles that it will have traveled. The second ship, 10 times 4, is 40 miles. This looks like a side angle side, so this is a law of cosines problem. So I don't know A squared, but I know 60 squared plus 40 squared are the two sides, minus 2 times 60 times 40 times the cosine of 48. Simplify that. And if you notice, I took the cosine of 48, which is about 0.6691. Now I'm going to take that times 48, and then 5200 minus that 3211.8269. Now square root that, And we get that it travels about 44.6 miles after 4 hours. That the two ships are 44.6 miles apart after 4 hours of travel. And then I've got 5 of them I want you to try on your own, please. Again, if you need more room, put the answers on this page, but put your work on another piece of paper.